Hello, my name is Nicole. This is a pre-recorded presentation for the 2022 meeting of the Society for Mathematical Psychology. Today, I'll be presenting my research on the specificity of the jumping to conclusion bias in social anxiety using the Bayesian computational modeling approach. The hallmark of social anxiety is a persistent and intense anxious response in social or performance situations that involve a possibility of evaluation from others. Cognitive models of anxiety emphasize that social anxiety is also characterized by biases in information processing, one of which is overestimating the likelihood of getting negative evaluation from others within minimal evidence. This suggests that social anxiety is associated with a reasoning bias known as the jumping to conclusion bias. However, the relationship between social anxiety and the jumping to conclusion bias has not been consistently shown. These inconclusive findings may be rooted in the nature of paradigm used. The classic BITS task is the gold standard in measuring the jumping to conclusion bias. This task involves presenting two jars that have opposing ratios of beads. One of the jars is randomly chosen and beads are drawn out of the chosen jar. Participants can usually request to see as many beads as they like before deciding the source of beads being drawn. Unbeknownst to participants, the sequence of beads presented is predetermined. In this task, the commonly measured dependent variables include the number of draws to decision and the subjective certainty about the source of bits drawn. Those who decide within two or fewer pieces of information in this task are considered jumping to conclusion. For the ease of communication, we term the most frequently occurring information in a given full sequence, like the red bits here, as the dominant bits. Likewise, the blue bits are termed secondary bits, which refer to the least frequently occurring bit color in a given full sequence. Given the abstractness and the absence of thread cues in the classic BITS task, one could argue that the information processing biases in anxiety will not be triggered in line with the propositions outlined by several cognitive models of anxiety. So far, only one study had investigated the specificity of jumping to conclusion bias in social anxiety. The social BITS task that contains self-relevant and delusion-relevant social threats was used. Examples of social scenarios in this task include making a decision on which waitress has made a critical comment about you, or which group is bored with your talk based on a series of socially salient information. The researchers found that clinically anxious sample requested significantly more bits in the classic BITS task, but behaved similarly in the social BITS task in comparison to healthy controls. Although these findings suggest that anxiety is not associated with the jumping to conclusion bias, we may argue that the social BITS task is not a suitable paradigm to investigate this reasoning bias in social anxiety because it was developed with a delusional theme and the socially salient scenarios have specified the negative outcome. So people only need to collect information to determine the source of negative outcome rather than using the information to interpret whether the scenario is threatening or not. Little is also known about any factors that could contribute to the jumping to conclusion bias in social anxiety. Cognitive models of anxiety emphasize that high anxiety is associated with a hypervigilance towards perceived threat and a lack of tendency to interpret information in a positive light. This suggests an uneven assignment of evidence weights to threatening information, which could contribute to a higher rate of belief updating within minimal pieces of information. Meanwhile, the fears of positive and negative evaluation could also explain the relationship between social anxiety and the jumping to conclusion bias. People with higher social anxiety experience heightened apprehension about being evaluated both favorably and unfavorably in social situations. This is due to a tendency to overestimate the probability and stake of social threats and the fear of increasing expectations from others following a good performance. Given fears of evaluation are self-defeating beliefs associated with catastrophic social outcomes, They could contribute to the biased assignment of evidence weights and therefore the jumping to conclusion bias. Given these gaps, the present study aimed to investigate the relationship between social anxiety and the jumping to conclusion bias using the Bayesian modeling approach, specifically through the assignment of evidence weights. We also aimed to explore the specificity and mechanism underlying social anxiety and the jumping to conclusion bias through the role of fears of evaluation. Here is the Bayesian model that we have developed and rigorously tested for its model properties in a simulation study. This model uses the variables measured in the BITS task to estimate the influence of a psychopathological trait variable on the assignment of evidence weights. The observed variables include the number of draws to decision, trial-to-trial certainty about the source of information presented, and the final decision about the source of information. The dominant and secondary information is allowed to have its individual evidence weights, which are determined by the person's trait variable. The parameters BAD and BAS are of interest because they capture the effect of the person's trait level on the assignment of evidence weights. The evidence weights assigned to the information sampled influence the rate of belief updating, which is reflected in the person's reported subjective certainty about the source of information drawn. This Bayesian model also assumes that the belief about the source of information drawn prior to seeing any information follows a random beta distribution with an uninformative prior. Once the person's evidence accumulated for a particular hypothesis exceeds a certain threshold, then the model assumes that the person will stop sampling and can now make a decision about the source of information drawn. In our study, we have analyzed the data using different decision thresholds, and the resulting estimations of the biases in the assignments of evidence weights are very similar. The final data analysis included 169 participants after excluding people who have failed attention and understanding checks. They completed a few measurement scales assessing various trait variables, but today we will focus on social anxiety and fears of evaluation. Participants also completed 3 versions of the BITS task: the classic BITS task that involved seeing colored bits, the social neutral BITS task which involved responding to non-threat related social information such as gender information, and the social anxiety BITS task which involved seeing socially salient information that indicates good or bad performance. Each variant of the task had 2 bits ratios reflecting different levels of uncertainty, and within each level of uncertainty there are 2 sequences presented. For example, sequence 1 in the social anxiety BITS task has dominantly positive feedback about a hypothetical presentation, which indicates a good presentation, and sequence 2 has dominantly negative feedback, which suggests a poor presentation. Altogether, everyone completed 12 BITS tasks. For each Bayesian model estimation, Markov chain Monte Carlo 4-chain processing was run with 10,000 samples drawn from the posterior distributions and the first 1,000 steps being discarded. All model estimations converged. The summarized results are based on a minimum of 9,000 samples averaged over 4 chains. Here you can see the trace plots for some models with the largest R-hat values in the current dataset, which still show that the random chains are mixing well together, indicating model convergence. All the DIC values for the more complex Bayesian model, which included a trait variable, are less than the DIC values for the simpler model without a trait variable. This suggests that the complex model has a better model fit. Let's focus on the results for the social anxiety BITS task first. In general, without considering the influences of any trait variables, the Bayesian model estimated that people placed significantly heavier weights on negative feedback in favor of positive outcome that suggests a good performance, and significantly heavier weights on positive feedback in favor of negative outcome that suggests a poor performance regardless of the sequences presented. This indicates an overall slower belief updating about one's social performance compared to a Bayesian agent. If we consider the influences of trait variables when mainly negative feedback was presented in the full sequence, social anxiety and fear of negative evaluation did not significantly bias evidence weights. In this condition, higher fear of positive evaluation was associated with significantly heavier weights assigned to positive feedback in favor of the more probable negative outcome of doing a poor presentation. Therefore, higher fear of positive evaluation might promote slower belief updating about performing poorly. On the other hand, when the full sequence consisted of mainly positive feedback, fear of positive evaluation had no significant influence on evidence weights. In this condition, people with higher social anxiety and fear of negative evaluation placed significantly heavier weights on positive feedback in favor of the more probable positive outcome of doing a good presentation, thereby promoting quicker belief updating about performing well. In the absence of threat cues, such as in the classic and social neutral BITS tasks, without considering the influences of trait variables, people generally placed significantly heavier weights on the most frequently occurring information in favor of the incorrect source of information, and significantly heavier weights on the least frequently occurring information in favor of the correct source of information. This again indicates a slower belief updating pattern compared to a Bayesian agent. In these neutral tasks, higher social anxiety was associated with quicker belief updating for the correct source of information. Meanwhile, the influence of the fear of positive evaluation on evidence weights is mixed, and the fear of negative evaluation is not significantly associated with evidence weights across both neutral tasks. Interestingly, our results also showed that people updated their belief at a similar rate as a rational Bayesian agent when the uncertainty level was the highest. However, people showed slower belief updating when the uncertainty level was the lowest at 90-10, as indicated by an increased deviation from the Bayesian belief updating after the second piece of information is drawn. Overall, our unexpected results provide new perspectives on the complexity of social anxiety, fears of evaluation, and the jumping to conclusion bias. Firstly, the slower belief updating pattern when the uncertainty level is the lowest suggests a general tendency to seek reassurance by gathering more information when the probable outcome is obvious. The present results also did not suggest a lack of positivity bias in high social anxiety and fears of evaluation that was observed in some previous research. One possible explanation could be that the information processing biases for social feedback may be delayed for people with higher social anxiety and fears of evaluation. For example, rumination could take place after the social situation, which then contributes to some form of reasoning bias that further cause negative effect. Furthermore, social anxiety is also associated with quicker belief updating in the neutral BIS tasks. These trends of quicker belief updating suggest that social anxiety may drive a need to avoid making incorrect decisions, thus contributing to a different way of evaluating information, which reduces reassurance seeking. Given the present findings, we have shown that our Bayesian model can be used with real-life data to understand evidence weighting of binary information. This means that the Bayesian model can be applied across a wide variety of settings, whereby scores from any measures can be used as the trait variable parameter to investigate the influence of that variable on evidence weighting. Future studies are warranted to further explore the causal effect of social anxiety on the jumping to conclusion bias. Finally, future research is needed to explore alternative explanations of this reasoning bias using other belief updating models. In a nutshell, the present study showed that social anxiety and fears of evaluation may be associated with the jumping to conclusion bias depending on situations. However, the biases in assigning evidence weights in social anxiety and fears of evaluation may be too weak to outweigh the general tendency to be overcautious in belief updating. So these variables seem insufficient in contributing to this reasoning bias. Thank you for listening, and please contact me if you have further questions.